Hi everyone. The lesson is Android Activities Part 2 Life Cycle of Activities. We'll be using these tools during this lecture and the references. You need to make sure you look at the previous lesson Android Activities Part 1 intro before you do this. You can find the link to that in the description. So in this session we will be learning the areas such as what is activity lifecycle, activity lifecycle concept, lifecycle callbacks such as on create, on start, etc., and activity state and when does it eject from the memory, and saving and restoring the transient UI state. So we'll be looking at this in this lesson. As usual, it's going to be practical demonstrations. So once again, getting into the developer API, developer docs actually. So this is where we stopped in the previous session about manifest, and just below that it talks about managing the activity life cycle. So it says over the course of its lifetime, an activity goes through number of states. You use a series of callbacks to handle transition between states, right? So what does that mean? So over the course of its lifetime, what does it mean? So for example, when I run this app develop, so we have two activities here. If you remember this app, so when I click send, it's loading another activity. So when it loads the second activity, certain things will happen to the first activity, such as if you go back, you don't see that message what you typed. So once again, if I show you, if I say hello and say send, and then if I come back, it's not there. So certain things are happening for the data and what's in the activity. So to understand what's happening, that's what we are talking here as lifetime or the life cycle and the callback method. So there are a couple of callbacks methods on create, on start, on resume, on stop, etc. That's what we are going to talk immediately. So look at the next link in the developer docs, the activity life cycle. So if I click on that, understanding the activity life cycle, let's look at this. So what does it mean? It says as a user navigates through, out of, and back to your app, the activity instances in your app transition through different stages in their life cycle. So what this means is when you say activity instances in your app, for example, now in this app, I got one activity here, and then when I click send, it's loading the second activity. So they are activity instances. So when I go back and forth, right? So I went to the next activity and coming back, certain things will happen. So that's what it says. When you navigate through and out of that, activity instances in your app transition through different status in their life cycle. So for that thing, what I did, there are certain life cycle activities which these activities will go through. Not only that, if you go from one app to another app, let us say I click the button over here, and then let's say if I select to go for another app, let's say my calculator app. Now when I move from one app to another app, also to the previous app, the activities in the previous app will go through life cycle method. So now you understand what this means, right? So if I go to another app contents, and then if I come back, so the activities in each of these apps will go through certain life cycle methods. That's what it talks here. So if you are an Android developer, you need to know what's happening to this what are the callback methods and what are the life cycle methods. So that's what it is. The activity class provides number of callbacks that allow the activity to know that a state has changed. So if you are a developer, sometimes you need to know when a state has changed in an activity due to the above reasons I said. So the activity class will give you callback methods for you to know what activity status have changed, right? That the system is creating, such as system is creating a activity, or system means the phone, right? The operating system. The say the phone is creating activity, the system, or stopping activity, resuming an activity, right? So when I say resuming, let's say I was in this activity, but I will be going to another activity, right? Then what will happen to that activity, right? So it let's say it's paused, for example. Then when I come back to it, it has to get resumed, right? So likewise, right? So within the life cycle callback methods, you can declare how your activities behaves when the user leaves. See, like I when I leave it, what do you want to do? So when I leave this, do you want anything to happen? So, and when I re-enter, right? So if I come back to it, do you want something to happen? So when the user leaves or re-enters the activity, right? Say for example, you are building a streaming video player, right? I'm just giving example. So then you might post a video and terminate the network connection when the user switches to another app. So if that was a streaming video app, let's say if you are doing running a streaming video app, but let's say all of a sudden user switch to another app like this, right? Then then you might post the video, right? Say that you then in that case you have to post the video and terminate the network connection, right? So you don't need it, no need the connection anymore because user is not now on that activity when the user is to another. But when the user returns, you can reconnect the network and allow the user to resume the video. So those things is what you handle through callback methods. So these callback methods or the lifecycle methods will allow you to perform these specific tasks, right? Okay. So good implementations of lifecycle callbacks, if you properly use these lifecycle callback methods, it can help you to avoid things like crashing the app, right? If the user receives a phone call, see for example, when the user is using the app, whatever you develop, let's say while the user is using this app, let's say all of a sudden the user receives a phone call. Now as you know, when you are on an app in your phone, Android phone, and if you receive a phone call, it gives the operating systems gives priority for the phone call app, so that this will be paused and the phone call app will come onto the full screen mode, and then once you are in the phone call, this app will not be in the foreground, right? So but once the phone call is over, this app will automatically come back, right? So if you uh, implement proper lifecycle callback methods, it can help you to avoid your app crashing in such instances such as phone call, etc., and also consuming valuable resources, because in the streaming app, when the user goes to another app, you don't have to consume the network resources, so you can close the connection such as, right, etc. You can avoid using losing the user's progress, right? For example, let's say the user is playing a game and let's say there's a current score, and all of a sudden the user receives a call, and then the app game will go into the say pause mode, right? But then once the phone call is over, when the game retrieves, you don't want to use the loser's progress such as the marks, the scores he had in the game, etc. So you have to take care all of them in the life cycle callback methods, right? So this document will explain this in detail, right? So then activity life cycle concepts. So this is very important for you to understand the activity life cycle concepts, right? So when an activity is launched, right? So what I mean by when an activity is launched is, let's say okay, let's do one thing, let's go back, right? So let's say if you are on the device home page, right? Let's say you go to the install apps and let's say you select on the app, right? So this means the activity is launched, right? So when the activity is launched, these are the callback methods or the life cycle methods that will trigger, that will fire, right? So let's go back, right? So these are the life cycle methods that will fire. So when an activity is launched, it will call a life cycle method call on create. Now for you to understand what this is, I will show you what when you develop your app. See, when you develop your app on you got a method call on create. So in every app you have a method call on create, especially in that on create method is where you did your initial, let's say accessing of certain items, etc., right? And not only that, even though we haven't discussed earlier, in on create is where it loads the XML file, meaning your layout file. This is the first time I'm telling it. It's loaded inside on create lifecycle callback method, right? So say set it's that layout XML is loaded with this method set content view. So for this main activity, it's loading the activity underscore main XML file, which means that is how this activity gets Java file gets connected to the XML file. That's how it is. Then the display message activity, the second activity inside the lifecycle callback method on create, see it loads the relevant layout XML file. So this one. That's how they are connected. So on create is a very important method. So after on create executes, then it goes for calls another lifecycle callback method called on start. But in these programs we wrote, we didn't use that on start method because it's not compulsory to use all these lifecycle callback methods. But once you finish this discussion, you will realize when there are instances where you might have to override this on start method or on resume method, though you haven't done it here. Now, why do I say override? Because these lifecycle callback methods comes from the parent class activity. So they come from the parent class activity, right? So which means if you look at the activity, the parent class, that is where you get uh, these methods coming from, right? So in the if you look at the API, right, this is the API. This from this activity class you get these methods inherited, right? So these methods are declared in that parent class, and what you are doing is you are overriding. So basically what you have done here is you are overriding the on create method. So when you finish this lesson, you will understand why when you have to sometimes override on start, on resume. So anyhow, after on create it calls on start, then it goes to on resume immediately, and then it doesn't stay on it, then it goes to activity running state. But then sometimes the activity can get paused, right? So for example, the activity is no longer visible, such as the user might have gone to another activity. But then when the user returns to this activity once again, like I showed you earlier, it will go to the on resume method, execute that, and then comes back to the activity running state. And sometimes the activity, while it's on pause, it can get uh, killed, right, due to high priority need of memory. If the device memory is limited, so if the app if the phone needs the memory for some other task, it might kill the activity while it's on pause. But after that, whenever the user navigates back to the activity, then it will again invoke on create because it has killed it. So then, for example, in that case, if it's a game, and if there are certain scores which you want, if you don't want them to lose, so what you have to do is on pause and on certain other methods, you can save that state and you can read it back in on create and put it back to the screen likewise, right? And then finally it can go to on stop, the activity is finished, right, or being destroyed by the system, right? Then it goes to on stop, and then it will call on destroy method and activity shuts down. So now you got some a reasonable idea of these lifecycle callback methods, and they invokes in a certain order and depending on the activities performed by the user. So let's quickly have a look at these one by one quickly. So for example, set content view. See, like set content view is, so some standard methods are being invoked by these lifecycle callback methods, important standard methods. Then on create, you must implement this callback. So that is, it's must. That is why in all the activities you will see on create. So you have to implement, you have to override it, because in that is where it sets the layout for the activity, right? It's connecting the layout, right? So on activity creation, the activity enters the created state. So it's entering this life cycle methods, right? So you perform basic startup logic in your application, right? We will do this practically in future lessons, right? So for example, you might bind data to a list inside on create. You might, if you got a list box, let's say you got a list box to display, then you can bind the data into the list in the on create, etc. Right? Likewise, right? And then, and this method receives the parameter bundle saved instance state. So it receives a parameters, as you can see bundle, see bundle type called saved instance state. In that means if this let's say if this activity crashes, and or if this activity is killed by the operating system, just before it gets killed, you can write the data into a bundle, and then once it's created back, once it's restored, you can read that bundle, this parameter, and restore the data. But in these simple apps we have developed, we are not doing it, but now you know that you can do it, right, after this discussion, right? Okay, the bundle object, we'll talk a lot more about that, right? See, for example, if there's a game state, say as example, right, there's a text view. So in the on create is it's super on create, that's always there, the super on create saved instance. And if the saved instance is not equal to null, that means if this variable is not equal to null, that means there is some data written. So it can be due to this app was running earlier and it got killed, but just before it got killed, one of the callback lifecycle methods, you have written some data to the bundle. So that is why when you read it back, it's not null, meaning it's not empty. So that means there's some data. So now based on the app logic of the app, you can use the saved instance, this parameter, and you can get the data back, whatever you have written to it, and put it back into your app, right? So we'll look at some of the practical exercises in a while, right? Likewise, and then you can once again say read the data and put it to the text view, etc., like that we have done in the past, right? So then, and then let's say this callback, there's callback call on restore instance state, right? But let's look at this on save instances. So this one is another callback method. So invoke the activity when the activity may temporarily destroyed. So earlier you saw sometimes activity can get temporarily destroyed due to, say, operating system needing some memory, right? So if you are developing an app, and in such case, if you want, when the app gets destroyed temporarily, if you want to save some data and retrieve it back when the app is restored, you have to override this method on save instance state. This is a standard method, you have to override it, and then you this method will be getting a bundle parameter. So to the bundle parameter you can put whatever the data you want, right? This is like a key value pair. So games type key is just some key, right? So some key, and then this is the value you want to save, some value, so some key and a value. And then you have to make sure you call the parent class on save instance state method. So you have to say super dot on save instance. So it's compulsory, so you have to make sure you call it. So when you write it on save instance state, and later when this app is restored, then you can read this data using another method called on restore instance state. Using the bundle you can get it, and you can, from that you can retrieve the data, whatever the key value pairs, you can give the key and retrieve the data and display the data, right? So this is something very important for you to understand. So we'll look at a practical for you to understand this, right? We will do a practical in a little while, right? But now the idea is you understand that there are certain life cycle methods, right? So then on start, right? So when the activity finishes, enters the started state, it will invoke this callback. So after the on create, it will go to on start, right? So this is another method. So you can override this. You makes activity visible to the user. So this will make the activity visible to the user, right? And as that prepares for activity to enter the foreground, so it will make it starting to visible to the user while the app is entering to the foreground of the phone, right? this method is where app initialize the code that maintains the user interface. So it initializes the real code over here. So on start completes very quickly, and then create with this state, right? Activity does not stay, right? Once it finishes, it will go to the on resume, the resume state. So then in the resume state, it will invoke the on resume method. Likewise, it goes very soon, one after the other. So now all this once again is what I'm referring here is to this diagram. So see, on create, on start, on resume. So now you know each of these states you can override and program them. So on resume, if you want something to do, you will do it inside on resume likewise, right? So for example, on resume, if you want to initialize the camera, let's say the camera module, say when you pause, let's say you pause the camera module, whatever, if the camera was on use, but on resume, you can once again display the camera module. So see, you can initialize the camera just as example on resume, right? And on pause, you can terminate the camera, right? Likewise. Then on pause is where when the system is putting the app to pause, let's say you go to another app, so that the current app will go to the pause state, likewise. So on pause, you can release the camera, for example, right? Now you are getting a clear picture. Then on stop, you can do another activity. Let's say, for example, let's look into this. So just before you want the app goes to on stop, let's see in this over here. So if you want to do certain things, let us say just before the app gets stopped, if you want to write to a database certain remaining data, right? Then in on stop, you can connect to the database and write it to the database, for example, right? So it depends on what you want to do. Actually, I'm just giving some examples for you to understand, right? Awesome, right? Then finally on destroy, right? So just before the app is going to get destroyed, right? This invokes this callback, right? Because the activity is either finishing, right, due to user dismissing, right, the activity app, the user might close it, so then it goes to on destroy. Or if the system is temporarily destroying, right, etc., then on destroy you can do whatever you would like to do. Then as I said earlier, sometimes if the system needs RAM to free up some RAM, the activity can get ejected or destroyed, right? Then it will be calling these certain methods, right? So, and if it gets destroyed like this, right, ejected and get destroyed, then you need, let's say you need to save and restore the state like we discussed earlier. See, for example, on save instance state, right? I just explained a little while ago. If you are not very sure, just go back and look at this video a couple of times, right? So the instance state, you have to write it and restore, right? And then for that, you can do it in more, if you have more complex data to write, you don't do it in this method. You will do it in a different way using view model, right? That we will discuss later under saving UI state in more detail, right? But if there's some simple data to write and to restore back, right, that is where you do it using these methods, right? So using on save instance state, which I explained a little while ago, right? So that is used to write some simple lightweight data using on saved state, right? We saw it little while ago in this video, right? But if it's complex, you will do it in a different way, right? See example, like I said earlier, in your app, let's say you have you need to keep keys, and let's say if before the app is destroyed, let's say you want to write the data, let's say the score of the game the user is playing or something like that, then as I said earlier in this video, on saved state to the bundle, you remember a little while ago I said to the bundle you can put a key and a value, right? And then later on restore, you can read it back as I explained earlier, right? Restore, once again, that can be done in on create even, right? So that's what I said at the beginning of this video. When it's getting created, you can put if condition to see this on create, which means this on create, the bundle you are receiving, whether it's not null, meaning there is some data. In that case, that means this app has got, say, destroyed, and it's getting restored. So then you have to read the data and put it back, let's say the current score and the current level of the game. I'm just giving example for you, right? It can be done in on create, or if not, it can be done, as I said earlier, in this method on restore instance state. So the idea of this lesson is for you to understand that these methods can be used to save and restore data, to recover data just before it's restored back after the app gets killed for some reason, right? We will do a practical for just and in a little while and show you this, but at the moment we are just discussing this, right? At the moment. Okay, so you got some theoretical understanding. So let's look at the slide and so we did some practical discussions, right? But the practical demonstrations will be done in the next lecture, right? So conclusion, you got a basic idea of life activity life cycle concepts, callback methods, right? And the state ejection from memory, right? And saving and restoring the UI state using certain methods, right? Especially saving lightweight data using on save instance state, restoring either on create or in the other relevant callback methods, right? So you can well, we didn't do a practical, so you don't have any option to download for this, but in when we do the practicals you will have it. We use developer docs, and look at the next part to complete this topic, and have a look at our other videos as well. So we are very excited to go to the next lesson, and let's see you in our next lesson.